When a person thinks of an ant, it is not unlikely that they would imagine a small creature scampering along a sidewalk somewhere in pursuit of some discarded scrap of fallen detritus. In most cases, ants are rather earthy creatures, constructing their nests in underground burrows. In more urban settings, they still often go to ground, excavating dwellings beneath the pavement. This tendency is by no means accidental. One of the key distinguishing features of an ant is a pair of specialized exocrine glands located on the back of the thorax. These so-called metapleural glands produce antifungal and antibacterial compounds, allowing these creatures to live in the dirt without worrying about the more unhygienic qualities of such a substance. Although most ant species live in the ground, this is by no means a universal pattern. A familiar exception would be the carpenter ants, which typically excavate homes in the remains of dead trees. That, or the occasional bit of lumber within a house. Even so, the nests of these creatures typically extend into the earth below the dead wood. There are other ant species that have developed a partnership with certain plants. Many acacia species host ant colonies, more or less bribing them into becoming an in-house defensive force. Such bribes often include nectar glands, protein-rich structures, and enlarged thorns filled with soft, easily excavated pith. The trees have become perfect homes for these aggressive little tenants. Still, an arboreal existence doesn't always require the cooperation of the tree. There are a couple of ant species that quite literally bend the plants to their will. These slender, almost lanky creatures inhabit the forest canopy and construct nests by pulling leaves together and binding them with silk. The result is a hollow structure that is typically anywhere between the size of a baseball and the size of a soccer ball. This unique nest design is the basis of their scientific name, and it also informs one of their more frequently used common names. The genus is known as Oecophila, which translates roughly into leaf house. They are more commonly known as weaver ants. Weaver ants tend to be quite abundant, with colonies numbering in the hundreds of thousands. Each colony is effectively a legion of tiny predators spread out among dozens of connected nests that may extend through the branches of several adjacent trees. Adjacent colonies often squabble for territory, and the more peripheral nests are functionally little more than soldier barracks. These colonies more or less dominate whatever patch of canopy they inhabit, and they take a heavy toll on the local invertebrate populations. Despite the remarkable ecological success of weaver ants, there are only 2 known species. Some specialists would contend that there are more, and the taxonomy is as yet poorly defined. Perhaps some of the subspecies will be reconsidered to be species at some point in the future. For now at least, let us simply consider the 2 species. Oecophila longinoda is found throughout equatorial Africa. The species name is most likely a reference to the long, slender build of these ants. The ants tend to range from reddish-brown to deep orange, and often stand out quite sharply against the green foliage they tend to inhabit. Oecophila smaragdina is found in tropical forests in India, Southeast Asia, northern Australia, and a number of southwestern Pacific islands. The species name here essentially translates into emerald. The ants of this species are sometimes referred to as green tree ants, and in some cases the head and abdomen do have a distinctly greenish hue. Still, in other cases, these ants are more of a uniform amber color. Color variations aside, a weaver ant is fairly easy to recognize. The creatures have unusually long legs and antennae and prominent dark eyes, the sort of build one might easily expect an arboreal ant to have. Another trait they share with certain ant groups is the lack of a stinger. This lack should not be misinterpreted. These ants are far from defenseless. Instead of employing a sting, they are able to spray formic acid from the poison gland in their abdomen. This abdomen, also known as a gaster in ants, is especially flexible in the case of weaver ants in particular. They can bend this gaster up and over their backs, allowing them to spray enemies that are directly in front of them. For deterring larger creatures, a combination of sharp mandibles to open a wound and a spray of acid into the wound can be quite effective. Beyond this, any acid sprayed into the eyes or nose would certainly be sufficient to deter all but the most tenacious of invaders. I suspect that the development of such ranged weaponry confers an advantage in a forest canopy. While such an environment can be rather densely packed with foliage, on the scale of an ant, it is a relatively open sort of place. Plenty of room for aiming and chemically attacking a creature while it is still some distance away, if necessary. When one considers the cooperation of hundreds of ants together, such a defense can be remarkably effective. In truth, these ants exhibit a greater degree of cooperation than many of the other ant species. More specifically, they appear to have a more complex and sophisticated language. The language of ants is based upon a combination of specific motions and a series of chemicals produced in various glands within the ant body. As these chemicals are produced to influence members of the same species, they are regarded as pheromones. Each pheromone may be regarded as the rough equivalent of a word or a specific idea. When combined with various behaviors, they can allow for a surprising degree of communication and coordination. Now, this is not to say that ants carry out highly complicated conversations on par with human language. Such communication isn't really necessary for the proper functioning of an ant colony. At minimum, maybe 10 basic chemical words are sufficient. Pheromones for colony recognition, coordinating brood care, laying foraging trails, sounding alarms, and other such daily business. Most ant species seem to have somewhere between 10 and 20 basic chemical signals. Weaver ants are at the 20 end of the scale, on par with a few other sophisticated sorts of ant. A number of myrmecologists believe that the weaver ants have the most complicated communication of any ant species currently known. This strong communication ability, combined with the highly aggressive nature of these ants and their capacity for ranged attacks, is all the more important considering the delicate nature of their nests. Compared to the earthen strongholds of most ant species, these nests are quite fragile. All the more reason to defend them with considerable force. Each nest also represents a considerable investment of time and energy. They are constructed in a manner that is quite unusual, with a few remarkable surprises. Early on, the ants will gather together into living chains to span the gaps between nearby leaves. They collectively pull the leaves closer together until eventually there is only one single line of parallel ants holding them in place. Typically, the jaws are clamped around the edge of one leaf, while all 6 legs grasp the other. At this point, the nest more or less has its final shape, but this is not really satisfactory for long-term structural stability. The ants have to get tired eventually, and it would be a waste of resources even if they held the nest together in shifts. Their time would be better spent with foraging and defense. An obvious replacement for these living leaf clamps would be the use of silk. Silk is not at all uncommon in the insect world, but there is a bit of a problem. Ants cannot make silk. More specifically, adult worker ants cannot produce silk. However, the larvae of ants are quite capable of making this substance. In most species, they employ this ability in the construction of their cocoons, giving them a place to pupate, insulated from the surrounding soil and its various potentially dangerous microbes. In weaver ants, this larval silk is put to a rather different use. While the ants are holding the prospective nest leaves in place, other ants arrive holding larvae in their jaws. They begin to move these larvae back and forth across the narrow gap between the leaves, gently squeezing them to persuade a silken thread to emerge. After a good deal of collective work from several such weaving duos, the leaves are secured and the ants can finally let go. All of this expenditure tends to leave the larvae without any silk for their cocoons. This isn't really much of an issue, though, as a cradle of leaves is a good deal more hygienic than an earthen burrow. So they simply pupate without a cocoon within the safe confines of one of the nests. It is worth noting that the grasping and pulling behavior used in nest construction can also be used in prey capture. Weaver ants can collectively immobilize larger arthropods, leaving them quite vulnerable. There is certainly no shortage of available ants to hold the prey down while others do the butchering. Their predatory strategies are so effective that these ants are often employed as natural forms of biological control in certain crop fields within their range. An active weaver ant colony certainly consumes enough to keep local pest populations well under control. This practice seems to be very old in certain parts of the world. Records from southern China refer to the use of weaver ants in protecting citrus groves, and some of these records go back as far as 1700 years. Interestingly enough, the weaver ants appear to be surprisingly ancient, despite their degree of sophistication. Specimens have been found in Baltic amber, at least 30 million years old, and they are recognizable as Oecophila of some sort or another. At least one species, Oecophila leakii, has been characterized from early Miocene fossils, estimated to be roughly 20 million years old. We can assume that these ants have been terrorizing the tenants of trees in the tropics for quite some time. In most cases, any creature that is small enough and unwary enough may find itself on the menu: arthropods, other invertebrates such as snails, even small vertebrates. It might seem that no creature is safe from this army of aggressive little insects, yet there are at least a few exceptions. These ants regularly tend to colonies of aphids and similar sap-sucking insects. These various sorts of Hymenoptera produce considerable quantities of honeydew, essentially sugar water, as a byproduct of their digestive processes. If there is anything that weaver ants like more than meat, it is sugar. This sweet tooth also leads to other curious associations. These ants sometimes care for the caterpillars of certain butterfly species within the family Lycaenidae. One example would be Arhopala maditis, commonly known as the bright oak blue. The Lycaenid caterpillars usually produce droplets of sugar water for the ants to consume, offering a similar payment to what the aphids offer. In at least one case, a Lycaenid species is distinctly more unpleasant. The caterpillars of Lephera braciolus are highly armored and lack the guile and manipulative abilities of their cousins. These tough little creatures manage to force their way past the weaver ant defenses, entering their nests to snack upon the larvae at their leisure, a grisly scene to be sure. Such is the case with even the best defenses in nature. Inevitably, there is one creature or another that finds a way around them, that or a way to trade upon the reputation of such ferocious creatures. There are at least a couple of species of spider that mimic weaver ants. This might grant them access to the nests, provided they mimic the colony pheromones properly. Cosmophasis bitaneata is a jumping spider that vaguely resembles a weaver ant and manages to find its way into their nests to dine upon their larvae from time to time. A much closer mimic in terms of visual appearance is another species of jumping spider, Myrmeplata platelioides. The female in particular looks very much like a weaver ant. The male has greatly enlarged mouthparts, which might vaguely mimic the appearance of a larva being held by a weaver ant. It would seem that such a resemblance discourages would-be predators from attacking these spiders. After all, attacking something that looks like a weaver ant is likely to quickly lead to the unwelcome company of a small army of angry weaver ants. For today, I would like to conclude with what may be something of an unusual observation on my part. While I was looking over the weaver ants, I couldn't help but notice a number of odd little parallels. By way of explanation, let me compare a more average sort of ant to a weaver ant. Compared to a more or less standard ant, the weaver ant is a tall, slender creature with prominent eyes and long appendages on its head. It lives in the trees, eschewing the earthen burrows of its cousins. Its nests are veritable palaces in the air, made of living material rather than soil. In a sense, it inhabits a realm that is altogether distinct from the ground, and quite literally on a higher level above it. The weaver ant employs a sophisticated form of language and exists in colonies that dominate its rarefied environment. So now, let us consider what such an equivalent might be in human terms. Suppose a standard ant was made equivalent to a human. What then would a weaver ant come to resemble? Anybody with a passing familiarity with fantasy novels might readily recognize a possible answer. A common trope within fantasy is the elves, speaking mainly of Tolkien's interpretation. Tall, slender beings that seem almost human but are somehow on a higher level, beings that inhabit a higher, more ethereal existence, often closely associated with forests and nature in general. So, from a certain point of view at least, the weaver ants may well be regarded as the high elves of the ant world, or at least the wood elves. Perhaps I'm seeing patterns where there are none. Certainly, I have been working on something rather fantastical of late for next week. Maybe some of the atmosphere found its way into my thinking this time around. Maybe, just maybe, I walked a little too far into the woods. I hope people might enjoy what I brought back from that walk next time. Thank you for listening. I hope you have enjoyed this brief glimpse into the more unusual side of the natural world. If you wish to know more, here are a few things that might be worth looking into. If you found this enjoyable, feel free to leave a like. If you think others would enjoy this content, by all means, share. If you have something to say or ask about, honest comments are always welcome. If you wish to see more from this channel, a subscription would be most helpful. Until next time.